So this lesson is going to be a little bit different. We're going to be going over how you dilate a line. So if you remember, a dilation is a transformation that creates a similar shape. But now we're actually going to be dilating a line. So it's not so much going to be about the size of the line, because a line goes on forever, but it's going to be more so about the distance of the line from a center. So there's a couple generic steps that we're going to follow every time. You're always going to graph the original line, right? And make sure that you have at least 2 points plotted, like distinctly plotted. You're then going to plot the center. You're then going to want to count the distance from the center to each point that you have plotted on the line. Write down those distances. Multiply the distances by your scale factor. Go back to the center and plot the new points using the scale distance. So you're going to count again, but instead of using your original distances, you're going to use your new distance. And then you connect your new points to find the new equation of the line. Once we do it a couple times, you'll see what I'm talking about. So first, dilate the line y equals x from the point 1, 1 with a scale factor of 2. So first thing I'm going to do is I'm going to plot my line. So we're starting at 0, and we have a slope of 1. So here's my line. And now I'm going to plot my center. My center is at 1, 1. So what we can see, right, is that the center of dilation is currently on our original line. So if I pick 2 other points on this line, right, I'll have point 1 and point 2. For point 1, to get from my center to my point, I would have to go over 1, to the right 1, up 1. So I would be going right 1, up 1. Now I multiply both of these by my scale factor, and so now I will be going right 2, up 2. And what you're going to notice is that when I do that, and I go right 2, up 2, my point ends up still being on the line. And if I repeat this with point 2, which would be right 2, up 2, times 2 for both, so I'm going right 4, and then up 4. My point again remains on my line. So if I connect these 2 points, my new line is the same exact one. My line remains y equals x. So when your center of dilation is on your original line, the line stays the same. So again, the first thing you want to check is to see, is your center of dilation on your original line? If it is, then your line does not change. Now we're going to tackle a second case. Dilate the line y equals x plus 2 from the origin 0, 0 with a scale factor of 2. So first let's plot our line. And now I'll do the center, which is at 0, 0. Now I want to choose 2 points on my line. So I'll choose point 1 and point 2. So my original point here, we're starting at 0, 2. Right, this is point 1. To get from my center all I have to do is go up 2. So my original distance is up 2. Now when I multiply it by the scale factor, I'm going to get up 4. So my new point for point 1 will be at 0, 4. Now if I look at my other point that I plotted, right, my original point here is at 2, 4. And my original distance is right 2, up 4, right 2, up 4, multiply both by the scale factor, and we get right 4, up 8. So again, I'm going to go back to my center, and I'm going to go over 4, and then go up 8 to plot my new point, which is going to be at 4, 8. And I count my Now you should notice a couple of things, right? So this is when we're dealing with the center of dilation is the origin. It's at the point 0, 0, right? If you notice, I started with 0, 2 and got 0, 4. I started with 2, 4, I got 4, 8. The trick here is that when you're starting with the center at the origin, you can say that you can just multiply the coordinates of your points on the line by your scale factor. And your resulting line will be a parallel line. So same slope, but different y-intercept, as long as 0, 0 is not on the line. Because if I go back and I determine the equation of the line, because that should be your final thing, right? My slope is the same, right? So my slope is going to stay as positive 1, and my new y-intercept is at 4. So this is your new equation. So you could just multiply the y-intercept by your scale factor and keep the slope the same. Now our final one, dilate the line y equals x plus 2, so same line as before. From the point 1, 1, with a scale factor of 2. So now our center of dilation is not on our line, and we're looking to see what happens. So I pick 2 points on my line, and I'm going to see what my distances are going to become. So my first point, which was 1, 3, right? Our original distance was just up 2. Multiply by your scale factor. So your new point will be found by going up 4. So our new point is at 1, 5. Now for my other point, I'm starting at 3, 5. And if I go from my center, I would have to go over to the right 2, 1, 2, up 4. multiply both by the scale factor. So I'm going to the right 4 and up 8. So I go back. I'm going to go to the right 4, and now I'm going to go up 8. So my new point will be at 5, 9. So now I connect my points. So now if I want the equation of this line, I can see the slope is remaining the same. So the slope is still going to be a positive 1. And wait a second. 2. To get that y is equal to x plus 4. So again, your line is parallel with a different y-intercept.